Hello everyone, welcome to the lecture on discrete mathematical structures. In this lecture video, we will be discussing about introduction to Rook polynomials and problems based on the Rook polynomials. To define this Rook polynomial, I will be considering a board that is same as a full chessboard or a part of chessboard. Let n be the number of squares present in the board and pawns are placed in the squares of the board such that no more than one pawn occupies a square. In the example we can see here, the board contains a rook and we know that always a rook will capture in the same row and same column. So by using this concept only, we will be framing the Rook polynomials. Okay, then the polynomial of the form 1 plus r1x plus r2x square plus so on plus rn x power n is called the Rook polynomial for the board considered in the previous one. So if the board is denoted by the notation r of c comma x and it is defined by r of c comma x is equal to 1 plus r1x plus r2x square plus so on plus rn x power n. I will be calling this as equation number 1. So while defining this polynomial, it has to be assumed that n must be greater than or equal to 2. So in some trivial cases, that is when n is equal to 1, we will be having always r2, r3 and so on till rn, all will be identically 0. Then the Rook polynomial r of c comma x leads to r of c comma x is equal to 1 plus x. This is when n is equal to 1. Similarly, r of c comma x is equal to 1 plus r1x plus r2x square plus so on plus rn x power n. I will be calling this as equation number 3. This is for n cross n board. I mean the board contains n number of squares, means we will be using this general equation. Problems. So now we will be seeing how to frame the Rook polynomial. So for that I will be taking a board containing 6 squares. So we can see the figure now. So from this figure I will be framing a Rook polynomial. So the thing is like, the first thing is we have to identify R1, R2, R3. So R1 is nothing but the number of empty squares in the board. R2 is given by finding 2 non-capturing rooks. R3 is given by finding 3 non-capturing rooks. So as I told, like capturing rooks in the sense the rook must move only in the same row and same column. Non-capturing rooks means it can move in any direction except same row and same column. So now this square contains 6 empty squares, right? So I can take the value of r1 is equal to 6 here. So now I will be finding the value of r1. r1 is nothing but finding 2 non-capturing rooks. So I can make 1 with 3, 1 comma 5, 1 comma 6, 2 comma 4, 2 comma 3, 2 comma 6, 3 comma 4, 3 comma 5. That's all. So I will be having here 8. The 2 non-capturing rooks are in 8 numbers. Similarly, I will be finding 3 non-capturing rooks. I can make 1, 3, 5, 2, 3, 4 I can make. That's all. So I will be having the 3 non-capturing rooks are in 2 in numbers. So as I explained, like since the board contains 6 empty squares, I will be having r1 is equal to 6 and the 2 non-capturing rooks can be having in the following positions, that is 1 comma 3, 1 comma 5, 1 comma 6, 2 comma 3, 2 comma 4, 2 comma 6, 3 comma 4, 3 comma 5, and they are in 18 numbers, and 3 mutually non-capturing rooks are 1, 3, 5, 2, 3, 4. They are in 2 in numbers, so the value of R3 will be equal to 2. Always we have to note that the value of R4, R5, R6 onwards, it will be always 0 for 3 cross 3 board. So now I will be incorporating all this equation in the Rook polynomial main equation. So in the place of R1 I will be replacing 6, in the place of R2 I will be putting 8, in the place of R3 I will be replacing 8. So 2. I will be getting RCX is equal to 1 plus 6x plus 8x square plus 2x cube is the required Rook polynomial for the given board. One more example. the board containing 8 squares marked from 1 to 8. So this is a board they have given. So for this board we have to frame a Rook polynomial. So now we'll find R1, R2, R3. As I told, like R1 is nothing but number of empty squares in the board. So since it contains 8 squares, the value of R1 will be equal to 8. So now we have to find R2. R2 is nothing but make a pair of two non-capturing rooks. So I'll be having 1, 5, 1, 8, 1, 7, 2, 4, 2, 5, 2, 6, 2, 8, 3, 4, 3, 6, 3, 7, 4, 7, 4, 8, 5, 6, 5, 7. And R3 is nothing but making 3 non-capturing rooks. So I'll be having the rooks like 1, 5, 7, 2, 5, 6, 3, 4, 7. And I can make 5, 7, 1 already over it is. Yeah. So now as I told, like since the box contain only 8 empty squares, the value of R1 will be equal to 8 here. And the value of R2 will be equal to 8. Yeah. So for this board I will be having the value of R1 is equal to 8. And this board having 2 non-capturing rooks are in 14 in numbers, that is 1, 5, 1, 5, 1, 7, yeah, 1, 5, 1, 7, 2, 4, 2, 5, 2, 6, 2, 8, 3, 4, 3, 6, 3, 7, 4, 8, 5, 6, 5, 7. They are in 14 numbers, so R2 is equal to 14. And the 3 non-capturing rooks are 1, 5, 7, 2, 4, 8, 2, 5, 6, 3, 4, 7. They are in 4 in numbers, so R3 is equal to 4. So now incorporating this value in the equation, I'll be getting the Rook as 1 plus 8x plus 14x square plus 4x. So since this all is 0 because of it is a 3 cross 3 board, for 3 cross 3 board R4 onwards it will be always 0. Next example, the board with the squares marked from 1 to 7 shown in figure. So for this board we have to frame the Rook polynomial. So first is since it contains 7 empty squares, R1 is equal to 7. So now R2 is making 2 non-capturing rooks. It is given by 1, 4, 1, 5, 1, 7, 2, 3, 2, 5, 2, 6, 3, 5, 3, 7, 4, 5, 4, 6. And making 3 non-capturing rooks are 1, 4, 5, 2, 3, 5. That's all. So I'll be having here 3. The 3 non-capturing rooks are 3 in numbers. So I can make the value of R1 is equal to 7. And the 2 non-capturing event, the rooks are 1, 4, 1, 5, 1, 7, 2, 3, 2, 5, 2, 6, 3, 5, 3, 7, 4, 5, 4, 6. It is 10 in numbers. And 3 mutually non-capturing rooks are 1, 4, 5, 2, 3, 5. So it is 2 in number, R3 is equal to 2. And for 3 cross 3 board, always from R4 to R8 it is 0 only. So by replacing all these values here, I will be getting RC of x is equal to 1 plus 7x plus 10x square plus 2x cube is the required Rook polynomial we got for the given board. Okay, in the next lecture video, we will be discussing few more problems based on the Rook polynomial only, but I will be using their expansion formula and product formula. Thank you.